Okay, we are on part 3 of the 3-part review. Hopefully it's only 3 parts. Hopefully we don't have a catastrophe of bathroom breaks or puppies having heart attacks. I don't know. Anyways, we have our last section of the review. For each of the following, identify the type of reaction, predict the products and words, change to formulas, and balance the equation. So basically, everything we've done in this review all at once. So we have 10 for chloride, okay? So mixing with fluorine. So this looks like this one. We have a metal, which is SN. We have a metal. We have chloride, which is a nonmetal. We have fluorine, which is also a nonmetal. So this looks like a single replacement, okay? And it also looks like we need to look on our activity series sheet to see if the nonmetals will switch places, okay? So fluorine needs to be higher than chloride. Fluorine is higher than chloride, so there will be a reaction and these will just switch places and that's it. You just make sure you change the endings and we're done, okay? Oh wait, we have to balance it. So we have 10 for switch places fluoride, okay, plus chlorine. That's it. Chlorine. Now we're not done. We would have been done here, but we're not done here. We're just incorporating everything. We've identified the type of reaction. We've done the products and words. Now we need to change the formula and then balance it. So 10 for chloride. 10 will be SN with a +4 charge. I know that because of this. Chloride is Cl -1. We're going to bring it down. So we have SN1, but we don't write it. Cl4 plus fluorine, which will come down, and that's one of the diatomic molecules, so it's 2. Remember, this is a diatomic molecule too, but again, I've said this a million times in class. You don't consider this monatomic or diatomic if it's part of a compound. Never do that. Only consider monatomic or diatomic if it's an element only. Will yield 10, so SN +4. I know that because of this. Fluoride +1. Okay, so we're going to bring them across. So SN1, we don't write that. F4 plus chlorine. That's a diatomic molecule, so it'll have 2. Moving on. 110, 110. We're good. 4 chlorines. 2 chlorines, okay, that's easy. 2 fluorines, 4 fluorines, so let's just add a 2. That was super easy. Okay. All right, so next one, silver bromate plus beryllium oxalate. So this looks like metal, nonmetal, metal, nonmetal. It's just a double replacement. Double replacement, okay? So we assume it happens and we just write our things. So basically double replacement would mean like this is going to go here and this will be with this one, okay? So they're going to basically switch partners. So we will have silver oxalate plus beryllium Hold on, I want to look at something on the periodic table. Okay, I thought so. This is spelled wrong. Okay, so beryllium. Beryllium is paired with bromate. That's it. You just switch them. And now you're just bringing down the formulas and then balancing them. So silver is Ag. Silver is Ag with a +1 charge. So silver, Ag +1, bromate. If it was bromide, we're looking on the periodic table. Since it's bromate, we're finding it here. Bromate, BrO3 -1. BrO3 -1. It's a 1-to-1 ratio, so we don't have to write any subscripts. So Ag, BrO3. Okay, plus beryllium. Beryllium is a metal because it's first, obviously, but beryllium's right here, so it's a +2 charge. So Be +2. oxalate. That is not oxygen. It would be oxide if it's oxygen, but it's not. So we're going to find oxalate somewhere. Here it is. Oxalate is C2O4 minus 2. C2O4 minus 2. So it's again, it's a 1-to-1 ratio, because if we were to bring it down, it'd be Be2 C2O4 2. But it's 1-to-1. We have to reduce it to its empirical formula because it's an ionic compound. That's something that was in last unit. So we're just going to write Be. I like to put my parentheses just to identify the polyatomic ions better. C2O4, but that's your preference. If you don't want to, don't. Silver, oxalate. So we know oxalate is here, right? So silver is a +1 charge. Oxalate, C2O4 minus 2. This we do need to cross down. So silver, 2, oxalate, 1. Okay, so we don't have to write the 1. Beryllium is a +2 charge. Bromate is bromate. That's not bromide, but bromate. I'm sorry, I already wrote it here. Bromate is BrO3 minus 1. BrO3 minus 1. So we will bring the charges down. So we have Be1, BrO3, 2. Okay, now we're just balancing. We have 1 silver here, 2 here. So 2 and 2, we're good. So 2 bromates, 2 bromates, and 2 bromates. 1 beryllium, 1 beryllium. 1 oxalate, 1 oxalate. So we're good. It's balanced. Okay. Moving on, we have sodium and sulfur, 2 elements. Going to combine to make a compound. So that is synthesis. Okay, so synthesis, and basically don't get them mixed up. That will be points off. You have sodium and sulfur. Make sure you put that sodium. It's the metal. Put the cation, the metal, the one on the left, whatever. It's all the same thing. First. So we have sodium sulfide. Okay, don't put sulfur sodiumide. That's not a thing. Okay, now we just have to bring it down and balance it. So sodium Na, that's not one of the diatomic molecules, so we leave it alone. Sulfur, not one of the diatomic molecules, so we just bring it down. Remember, you don't have to worry about charges on elements. It's really easy. Sodium sulfide, now it's a compound. We do. Sulfide is, so sodium is here. It's a +1 charge. Sulfur is here. That's a -2 charge. So -2, so cross them down. So we will have Na2S, okay? Now we're just balancing. We have 2 sodiums. We need 2 sodiums here. 1 sulfur, we're done. Boom. Easy, right? Aluminum chlorate. This looks like a decomposition, but we have one of our 3 exceptions to our decomposition. We have that chlorate, okay? So that means whatever this decomposition is, it's whatever the metal was, chloride. Sorry, if it's chlorate, it's chloride, okay? And this is, again, if you look in your double replacement, your decomposition notes, it tells you, like, right there, chlorate, what was the other one? Chlorate, carbonate, and hydroxide, they all have their own little, this is always the ending type rule, okay? So we have whatever that metal is, chloride, plus oxygen. Almost forgot. Okay, so when you have a chlorate, it's whatever the metal is bonded with that chloride plus oxygen. This always stays the same. This will change depending on what this metal is. So just write aluminum. Okay, aluminum. That's it, aluminum chloride plus oxygen. I'm sorry I didn't write that down. This is decomposition. Now we have to bring it down and balance it. So aluminum chlorate. So aluminum is Al plus 3. I know that from the periodic table right here, Al plus 3. Okay. Then we have chlorate. So chlorate right here, chlorate, ClO3 minus 1. ClO3 minus 1. We cross them down. So that means we have Al, we have one of them. Chlorate, ClO3 with a 3. Okay, don't forget that. Don't forget. Aluminum chloride, so that's ionic, +3. Chloride, Cl -1. Okay, cross them down. Al, Cl3, plus oxygen, that's an element. Is it monatomic or diatomic? It's diatomic because it's on the list. O2. Now we balance it. So we have one aluminum, one aluminum. We have 3 chlorines, 3 chlorines, so we need to change that. Oh, this is going to be 3 chlorines, 3 chlorines. My bad. Okay, sorry. Start over. 1, 1, 3, 3. Okay. Oxygen, 3 times 3 is 9, so we have 9 oxygens and 2. Okay, so here's where we get to the point where we don't like it. So remember when I told you, like on the other page, where you use the subscript as the coefficient, okay? And then this is a subscript as the coefficient. That's really the only way I can like think of how to explain it. Because that gives you the lowest number where they'll balance on each side. So we have 2 aluminums, we have 3. So let's change that. 2 aluminums, not 3, 1. Oh my gosh. 1. So 2 and 2 now. We have 2 times 3, so we have 6 chlorines. We have 2 times 3, that's 6 chlorines. We have 3 times 3, so that's 9 oxygens times 2, so that's 18 oxygens. We have 9 oxygens times 2, that's 18, so we're balanced. So this is one of those where you have like an odd number, you have 9, and then you had 2. So you just, the subscript of 1, put it as the coefficient of the other. This is a subscript of 1, coefficient as the other. I mean, you could just go back and forth, but that's like a good trick, I guess. It's not really a trick. Anyways, moving on. Zinc plus iron 3 chlorite. So this looks like one of the Mr. Steal Your Girl equations, so single replacement. Now we just have to find out if zinc is going to be higher than chlorite. Okay, so we're going to look on our activity series list. So zinc needs to be higher than iron for this reaction to occur. Here is zinc. Iron is right here, so it is higher than iron, so this reaction will occur. So they're just going to switch places. So we're just going to have iron, and it's going to be an element, so we don't have to worry about that, what's it called, Roman numeral. We just write iron. Then zinc's going to be paired with chlorite, so we will have zinc. And if you'll look, zinc has only a +2 charge, so we don't have to write a Roman numeral. So zinc chlorite, okay? So now we just bring down the formula and balance it when we're done. So we have zinc. It's not diatomic, so we just bring it down elementally. Iron, it's a +3 charge because of this guy. Okay, chlorite. It's not on the periodic table. That's chloride. So chlorite is here. ClO2 -1. So ClO2 -1. That door, I'm so sorry, guys. So we have iron, 1, but we don't write it. Chlorite, we have 3 of them. Yields, iron is just Fe. We don't have to worry about Roman numerals. It's not diatomic. We just bring it down and we're done. Zinc chloride. So zinc is a +2 charge. Chlorite, like over here, is ClO2 -1. Cross the charges. And as of now, most of our tests will be with ionic compounds. There's only very few. Do I have it? Hold on. Where's my other page that it? Here we go. We only have like 1 or 2, if any, on your test that will have, where is it? Here, that will have a covalent bonded. So most of them are going to be do the charge and cross it down type things. Anyways, so do the charge, cross it down. We have zinc, 1 zinc, we don't write 1. Chlorite, we have 2 of them. Now we need to balance it. 1 zinc, we're good, but I doubt it's forever. 1 iron, that's good. 3 chlorates, 2, we have to do the thing. So we have 2 here, so we need to put the coefficient of 2 here. We have 3 here, so the coefficient of 3, that's a 3, wow, goes here. So let's check and see. We have 3 zincs, let's change this to 3, 3 and 3. 2 irons, we need to put a 2 here. 6 chlorites, I think I was saying chlorides, but whatever. 6 chlorites, so we're balanced. That's it. Last paper. Woo-hoo-hoo. All right, so we have copper plus cobalt, 2 oxalate. So this looks like, again, a single replacement. Let's look at our activity series sheet and see if copper is higher than cobalt. So we have cobalt. Copper is lower, so actually there's no reaction. Yes, I was hoping for that because I am tired. No reaction. That's super easy, okay? All right. Next, we have beryllium and phosphoric acid. Again, this looks like another single replacement. And then we have to check to see if beryllium is higher than, oh, what are we checking to see if it's higher than? It's an acid. So we need to write it as like its little ionic type thing. So hydrogen and phosphoric. So there's no hydro, so it's not "-ide". There's just the "-ic", so it ended in 8. So we're looking at hydrogen and we're looking at phosphate. Okay, so we're going to check and see if beryllium's higher than hydrogen to see if it'll switch places, which I'm sure it is. Most is it higher than hydrogen. Here's hydrogen. Beryllium is all the way up here. So yes, it is. They're going to switch places. So we will have beryllium, phosphate, plus hydrogen. That's it. Okay. Now we bring the formula down and balance it. So beryllium is just an element, Be, it's not diatomic, we just bring it down. Hydrogen, phosphoric acid, so all acids start with an H. Phosphoric, so phosphate, okay. So phosphate looks like this, right here. It's PO4 minus 3, so PO4. And that 3 can just go here, okay, because hydrogen's always +1, and whatever this is, just bring it down. This will always be 1. We don't ever write the 1, so that's how you just always know that it will go here. Beryllium phosphate, that's Be. Beryllium is on the periodic table right here. It's a +2. It's a +2 charge, okay. So beryllium, +2 charge. Sorry, my phone battery is about to die, so I'm trying to hurry. Phosphate, that's on our list. So phosphate is PO4 minus 3. PO4 minus 3, cross the charges. So that's Be 3, PO4 2, okay, plus hydrogen, and hydrogen's one of those diatomic molecules, so you bring it down like that. Be, you have 1 of them, you have 3 of them. Change it. Hydrogen, you have 3, you have 2, you do the coefficient to whatever, so the 2 will actually go here, this 3 will go here. So now we have 6 hydrogens, 6 hydrogens. 2 phosphates, so we're balanced. Done. Okay. Now next, for the following combustion reactions, predict the products and balance the equations. So remember, you'll have to remember what you will have on this side if you have a hydrogen, or if you have a sulfur, or if you have a nitrogen, or if you have a carbon. They all will yield something. So we have a hydrogen, okay? So we know we're going to get water, okay? We have a sulfur, so we know we're going to get SO2, the oxide of sulfur. We know we have nitrogen, so we know we're going to get nitrogen, okay? Now we just have to balance it. So we have, this is going to be fun. So we have 2 hydrogens, 2 here, okay? Probably not going to stay that way, but that's okay. So 2 hydrogens, sulfur, we have 2 sulfurs, we have 1 sulfur, so we need 2 here. Nitrogen, we have 2 nitrogens, so that's good. So let's check and see. Oh, and we have oxygen, we have 2 oxygens, we have 2 here plus 1. So maybe put a 2 here and a 2 here. So we'd have 4 here, 2 plus, oh, that's 4. 3. So we have 6, 2, 4. Okay, let's look. I think that it is not good. Remember, we might have to do either the 0.15 to balance this out. Let's check. 2 hydrogens. We have 4 here now. Okay, so we've messed that up. So we need 4 here. Okay, so we have 4 hydrogens, 4 hydrogens, 4 sulfurs, 4 sulfurs. That messed up our oxygen. Just keep that in mind. We have 4 nitrogens. Okay, we have 2 nitrogen and 4 nitrogens. Okay, so let's look at this. Our oxygen, that's the thing that's going to keep changing, and we're going to do it as a decimal if we want. 4, 4, 4, 4, 4, 4. Let's look at our oxygens. We have 2 oxygens plus 6 oxygens. So we have 2 plus, actually that's 8. So 8, 2, 8, that's 10. So 5. So that should be balanced. 4, 5, 4, 2, 2. Yeah, I think we're good. Okay, that is a gross equation. I don't like it. I don't like it when it gets weird, but that's okay. It's a fun puzzle, I guess. All right, so last combustion one, it has carbon, so I know I'm going to get CO2. It has hydrogen, so I know I'm going to get H2O. Just balance it. So we have 3 carbons here. We need 3 here. We have 8 hydrogens here. We need 8 hydrogens here. Okay, so we have 3. So now we need to balance our oxygens. We have 4 plus 6, right? So we have 4 plus 6 oxygens. So 4 plus 6, that's 10. So we need 5. That one was less painful. All right, guys, so that should be it. Hopefully that helped you get ready for the review. Hopefully that helped you prepare for the test. If you want to see something cute, maybe your brain is fried. Fisticky. Hi, Fisticky.
Wait.
Okay, bye.
Bye.